So here I want to tackle, I've been asked multiple times about quiz 2 number 6, and this is the one where they give you the matrix. In this case, I'm going to use the matrix -1, -3, 2, 3, 1, 1. They give you a column matrix, and they call it B, and they ask you to write B as a linear combination of the columns of A. A linear combination, just in general, means that you're going to take, in this case, the columns of A, and write them as the first one times x plus the second one times y plus the third one times z, where x, y, and z are integers. So we're trying to find integers x, y, and z so that we can write B as, so that we can write this as equal to x times the first column plus y times the second column plus z times the third column. So that's our goal. And if you take these constants and distribute them through the matrix, you're just taking a matrix times a constant, you would end up with -7, 7 is equal to -x, 3x plus -3y, y plus 2z, z. And then if you add the corresponding entries, compare the corresponding entries, you end up with two equations and two unknowns. You end up with -x minus 3y plus 2z is equal to -7. You also end up with 3x plus y plus z is equal to 7. And then you want to solve the system, and you want to specifically look for integer solutions. So what we're going to do is we're going to write this as a matrix and just pretend that this has no other context and we want to solve the system. So we can write this as -1, -3, 2, -7. Remember, I like to put the dots to represent the equal signs. The book does not, for whatever reason. That's okay. And then the bottom row will be 3, 1, 1, 7. And we want to reduce this as much as possible. So the first thing that we can do is just take all of row 1 and change that to be negative row 1. So we're going to take all the values in row 1 and multiply by -1. That changes all of their signs. Everything else stays the same. For the second step, we're going to take a multiple of row 1 and add it to row 3 so that we get a 0 there. It looks like we're going to need to take row 2 and replace that with row 2 minus 3 row 1. So if we take minus 3 row 1, add that to row 2, we'll get 0. So that means that our next step in reducing, so the first row I'm going to copy. The second row is going to be 0, and then we need to calculate the rest. We're going to have 1 minus 3 times 3, so that's -8. 1 minus -2 times 3, so that's 1 minus a -6, so that's a 7. And then 7 minus 3 times 7, so that'll be -14. Okay. Now what we're going to do is take row 2, divide by -8. This should all be normal stuff at this point. So we're going to take row 2, divide by -8. Leave the first row alone now. And what we'll get is 0 and 1 by design. We'll get -7/8, and then we'll get 14/8. 14/8 is the same as, you can cancel a 2 out of each, so that's 7/4, and then 7/4 is as reduced as this gets. The next and final step in finding the reduced to echelon form is to get this 3 to be a 0. So that means that we're going to take row 2 and add a multiple of it to row 1 and replace that with current row 1. So row 1 is going to become row 1 minus 3 row 2. Because again, you have to take -3 times the second row plus the first row to make that a 0. We're only changing row 1, so I'm going to copy down row 2. So we get 0, 1, -7/8, 7/4. In row 1, we're going to get 1 and 0 by design. So the 1 doesn't change, the 3 becomes a 0. And then we need to figure out what the rest is going to be. So if we take -3 times negative 7/8, that's going to be 21/8, minus 16/8, so that should be 5/8. And then if we take 7 minus 3 times 7/4, so that's going to be 7 is 28/4, minus 21/4 will be 7/4. So those happen to both be 7/4 on the right. And then we can interpret this again as, basically at this point we can find a parametric solution to the system. We know that x plus 5/8 of z is equal to 7/4. We know that y minus 7/8 z is equal to 7/4. And if I wanted to be very certain that we're going to live in the integers, which is what we're after, is integer solutions to the system, one thing that we could do is just clear out the denominators right now. So let's multiply both sides by 8. I know that that undoes some of our hard work of finding the reduced or echelon form, but let's multiply by 8. So we're going to end up with, actually, let's wait. Maybe we don't need to do that. We might need to do that at the end, but let's see how it goes. Let's let z be t, and then we know that x is going to be 7/4 minus 5/8 times t, and we know that y is going to be 7/4 plus 7/8 times t. And now we need to think about what are values of x, y, and z that are all integers, so that these all work. So let's think about what we could do. If t is equal to 2, I'm just trying to find values where x and y will be integers. So if z or t is equal to 2, let's think about what that means. That would mean x is 7/4 minus 5/4, or 1/2. So good effort, but that's not an integer. If t is equal to 2, then y would be 7/4 plus 7/4. So again, 7/2, not an integer. So let's try t equals minus 2. That would again give you fourths. And then we're going to end up with x is 7/4 plus 5/4. And that is an integer. That gives you 3. Y would be 7/4. And if t is -2, then that'll be minus 7/4, or 0. That's also an integer. And so it turns out you can take x to be 3, y is 0, z is -2. In other words, you can take 3 times a1 plus 0 times a2 minus 2 times a3, and that will give you your b, which is -7, 7. Here, remember, a1 was the column matrix -1, 3. a2 was the column matrix -3, 1. a3 was the column matrix 2, 1. So that will give you your solution here.